Good evening. My name is Dr. Arewa from Lagos State University, Department of Banking and Finance. This evening I'm delivering a lecture on Artificial Neural Network, ANN. Artificial Neural Network, ANN. ANN is part of the family of artificial intelligence. Artificial intelligence, and it is considered as a simple mathematical model that combines neurons together to make prediction. That is, it is an algorithm. It is a system of neurons, what we call nodes. It combines nodes together at different layers to make prediction. Essentially, we have three layers. We have the input layers, we have the hidden layers, we have the output layers. In the input layers, we have the predictors, explanatory variables. Then in the output layers, we have the explained variable, that is the variable to be predicted. Now, if the input layer is linked directly or linearly to the output layer without the hidden layers, that is a simplex ANN model. And in this model, a linear regression method can be applied because there are no hidden layers. But in an instance where you have a hidden layer, or where you have hidden layers with hidden neurons or nodes, then a linear method like OLS cannot be applied. A method that can be applied is called nonlinear methods. This can be represented, a simple ANN can be represented dramatically as you have the input layer. We have the input layer that comprises input variables, predictors, explanatory variables, independent variables. For example, assuming we have 4 independent variables, the first inputs, the second inputs, the third inputs, and the fourth inputs. This is input 1, which could be called opening price, opening price of an asset. Then input 2, we can call it close price of an asset. Then input 3 could be called low price, the lowest price of an asset at a particular time. Then high price, that is the highest price of an asset at a particular time. This, like I said, this is called the input layer. Then, if we have the output layer here, output layer that comprises the variable to be predicted. For example, maybe we want to predict close price. That is our output layer. And then we can now connect them to the input layer to the output layers with arrows. Each of these arrows represent a width. Now, these output layers becomes outputs for the next layer, which is the last layer, called the output layers. So like I said, we have the bottom layer, which is the input layer. We have the top layer, which is the output layer. So when they are connected together, in the absence of the hidden layers, it is called simple artificial neural network system. However, there are cases where we have hidden layers, and such cases it is a complex. It's a complex artificial neural network. For example, if we have intermediary layers called hidden layers between the input layers and the output layers, we could have here hidden layers. Assuming we have 3 nodes or 3 neurons. These are called neurons for the input layer. These are the neurons or the nodes for the hidden layers. Here we have 1 hidden layers and 3 neurons. And we can connect them together with the weights. That is the first connection. We've connected all the outputs to 1 neurons in the hidden layers. And we will repeat that for the second neurons and also repeat that for the third neuron as follows. Then, having done this, we have the hidden layers, we have the output layers. We have the hidden layers, we have the input layers. Then we can now have the output layers. And the output layers, we can now connect the hidden neurons to the output layers. Output layers. So, looking at the weights of each of these hidden layers, we can have the expression as follows. The expression as follows to combine all the weights that goes to the hidden layers. Like I said, in the hidden layers, we have the outputs of the previous layers. That is to say, the input layers becomes outputs for the hidden layers. Then the outputs, the inputs of the hidden layers become output for the output layers. Now, by this expression, we'll be able to combine the weights of each neurons for each hidden layers. Let's take neuron J. Neuron J is equals to Bj plus summation I, taking value from 1 to 4, because we have 4 nodes or neurons in the input layer, the bottom layers We have 4 neurons. And so therefore, we have sigma I taking value from 1 to 4. Then the weights ij xi. This will be able to combine all the weights in nodule J or in neuron J for the hidden layers. Now, because this is a non-linear function, because we are not directly relating the input layer to the output layer. We are relating the input layer to the output layer via the hidden layer, and so it is a non-linear function. And we have to look for a non-linear function such as Zygmunt to Zygmunt. To express the non-linearity among these variables. That is to say, artificial intelligent neurons reveals a non-linear relationship between output variables and input variables. So therefore, xz is equal to 1 over 1 plus e raised to power minus z. With this, we will be able to estimate the weights and the parameter j's for each of the hidden layers. And maximizing the cost function, we can now maximize the cost function. And one of the cost functions that we can maximize is mean square error. Mean square error. We can maximize the mean square error to obtain the weights of this function, which we are going to do in the next stage of this presentation. Meaning that this is stage 1. In the next stage of this presentation, we are going to maximize the weight and we are going to make prediction for the output variable using neural network algorithm. Thank you so much.